code-free data analysis. And thank you, Erin, starting the recording because I had forgotten. Um, so I'm going to give you a ton of content today. And like I said, too many slides, so I'll be going pretty quickly. But Erin Foster, who is the service lead for research data management, is here with me and will be monitoring the chat. There's also the collaborative notes. So if you have a question that you think won't really work out for today, but you want to enter that for me and or Erin and or colleagues to see and get back to you, happy to do that. There's the slides will be available, so you'll be able to get all of the links and stuff. So don't worry about that part. My slides are super, super, super dense. So apologies in advance, but it does mean that you'll be able to go back to the content later. And as you probably heard, we are recording. And once that is closed captioned, it'll be up on the Love Data Week site. My name is Ann Glusker, and I am the librarian for a number of social sciences disciplines here at Berkeley, and also the librarian for research methods. And part of my passion for this topic is I used to be a public health epidemiologist for some time here in Seattle, Washington, and I answered data requests from the public. And so I was very used to how people could have kind of some agency in exploring data for themselves. This presentation is part of UC Love Data Week. Link is here at the bottom. And we'd love for you to check in on our other events this week. I will be doing a presentation on Friday on qualitative data analysis if today whets your appetite for that. So just a little bit about why I'm even doing this workshop. I had a colleague who had a student come to her and say, I have an assignment, and my assignment is that I have to go and find a data set somewhere, somehow, and analyze it somehow, although I've never done it before, and come up with brand new findings. And this student was thinking that they would have to learn R or Python in the space of a week to do this assignment, and was kind of at her wit's end. It was at her wit's end. And I said to my colleague, well, okay, ICPSR has online analysis. You could just kind of go there and get some good stuff, and it would take you 5 minutes maybe. And she said, oh, I didn't even think about that. So it occurred to us that maybe this would be a useful topic for folks. So here we go. This is what I'm intending to go through today. I'm a little bit nervous that some of you are sort of looking at this list and thinking, oh, this is not what I thought it would be. Fair enough. No worries. Feel free to take off if your time is better spent. But what I'm going to be sort of talking about, I'm going to give you sort of an overview of what the coding is in terms of this workshop. A little bit about coding and AI, which is on everybody's minds. We're going to look at a few interactive data tools. You can see that the topic list is getting to be pretty long, so I'm not going to go deeply into anything. That will be up to you afterwards. I'm going to be looking at some tools where you can upload your own data, some advanced features of familiar tools such as Excel, Google Sheets, that kind of thing. I'm going to talk about data visualization and storytelling as ways to do code-free data analysis, which we don't always think of them that way. A research methods resource and how to get more help. And here is the URL for collaborative notes. So if you weren't here right before we started, I do have this collaborative notes page because I just feel 100% for sure whenever I've been to workshops like this that other people have given, there's such great stuff in the chat. And maybe part of this is that I'm sad to not be seeing the chat as I present. So please, please share with everybody resources that you've used about or reactions as I'm speaking, or, it's some of these things I've only kind of come across quite recently, and I may be missing things about them or forgetting to talk about problems and issues that you know about, but I don't. So please put all of that in the notes. I appreciate it. So, okay, getting into it. What do I mean by coding for the purposes of this workshop? I'm talking both about creating code, and you'll see some examples of code in a second, to categorize data to get it ready for analysis. So a little bit later, we'll look at some raw data that is not what we would call clean. So it has like missing stuff and weird entries that you have to kind of fix before you analyze it. And then also the commands that you would use to perform analysis. So if you want like, how many people live in which county, if it's a statewide data set. Generally, you're doing both of those things in one platform. It could be R or Python, which are languages. It could be a statistical package like SPSS or Stata or SAS. But we're going to be looking at ways to do that without using those platforms. I'm mostly going to be looking at social sciences data and mostly secondary data, meaning someone else has collected it. I haven't collected it. Apologies for that. If you're interested in data from a different field or data science methods, we're not going to be getting into that very much, but a lot of it will apply across disciplines. So I do hope you'll stay with us. And this session, not surprisingly, will focus more on quantitative data. But as I say, I will be giving a session on qualitative on Friday. So I went back into my files from when I was an epidemiologist and found some code I wrote back in the day. Look, it's like a 20-year-old code. Even back then, we were coding. This is in Stata. And I was in the health department, and I had a big old data set that was had a variable, so information in a column about whether or not people were insured. And to get numbers out of that, I had to use 4 different variables. So I used age. So where you see strata, that's layers. So it's actually age categories, whether or not they had insurance, what year the data were from, and then a weight. And part of what's so complicated about trying to do data analysis without any code is that you really do have to be thinking about how each case is weighted. So if you look in the upper right where it says number of observations, and it's like 4,200 observations, that's how many people they asked about insurance. But then if you look at the population size, it's 3.4 million. So what you're doing with the weights is you're using statistical techniques to make sure that those 4,200 people's answers are representing the whole population. I could say much more, but since I have a whole bunch more slides as I keep referring to, I won't. But if you have questions about that, you can put them in the collaborative notes document. Anyway, so this is what the code looks like, and this is the table that came out. So we see out of everybody, and all means all regions. Oh, no, means all ages, sorry. There's about 10% people that do not have health insurance. So all of that is to get that one number. I do also want us to be thinking about data as patterns in general. So this slide is a little bit weird and off track, but I couldn't resist it. Because one concern I have is that part of the message today is that coding is hard and code free is easier. And I don't want that to be the message at all. I don't believe it's true. I believe we're all really, really good at thinking in codes, examining patterns. I mean, even if you're using websites to pay your bills, you are actually using code without thinking about it. So I do want us all to feel like code is accessible to us, but there's a learning curve. So if you have a tool that you don't have to learn the code, why not use it? So that's kind of the point of this slide. And you can explore it later, but it's kind of cool. So getting back to data, like why would you want to be using code? Well, we just talked about that issue of having the number of observations try to weight up to the full population. And that may be something that you want to have some control over how you operate that. So you might want to have that kind of level of control by using code. If you want to use microdata as opposed to aggregate data, what do I mean by those terms? Microdata would be the Excel spreadsheet, basically, or the Google sheet. We'll see an example of that later. That's row by row. So if it's census data where they come to each house and ask people, each row is a house. The aggregate data is where the Census Bureau collects it and says, here's the number of houses with working toilets or whatever it is why is that what came to mind? But something that's already aggregated and pre-analyzed. So easier perhaps to analyze microdata with code. Complex statistical questions and methods, you're probably going to need to know how to code. wrangling big data, you are certainly going to need to know how to code. So you're not really going to be able to do that with the tools I'm going to show you. But maybe you don't really need to do any of those things. So where do you go next? Well, first, before we kind of delve into where you go next, let's just talk a little bit about coding and AI. So I kind of love this example. Like if you read these key points, basically, artificial intelligence, and specifically the tool that we're hearing the most about and maybe the most familiar with, ChatGPT, can do a lot of unexpected things. I have friends that plan their vacations with it. I mean, who would have thought? So you actually can ask ChatGPT to give you the code to perform a data analysis in R. So you wouldn't actually have to know R to create the code. You could get it from ChatGPT. So my two questions are, what could go wrong and what could go right? So what could go right is, let's say that you are a new user of R. You might actually learn something from looking at the code that is generated by ChatGPT. You might want to do a quick analysis that you don't feel like figuring out how to do the code, or maybe you think to yourself, this is a pretty common thing. I've never done it before, but someone has. Why shouldn't I use their code? And people are very generous about sharing it. So that's not anything wrong ethically. What could go wrong is if you don't understand what the code is doing and you don't understand the data. And one thing that I'm going to probably keep saying so many times that you get sick of it is that none of this is a substitute for understanding the underlying data and how they were collected and what they represent. If you don't know your data and you don't really understand what the code is doing, you are not in a position really to critique the result and stand behind the result. So one thing that we as librarians are starting to say is, you know how you're all kind of used to doing a literature review and saying, well, so-and-so said this, but they did their analysis in a weird way, so let's revisit or whatever. When you're getting your stuff from AI, no one is responsible for it. So there's no one to blame. So you have to really be on top of it. Another AI example was this one, which kind of, to me, was like really cool and really scary at the same time. So this is kind of saying that you can approach even data science, even like working with bigger data sets and stuff, with no code, because what you're doing is you're basically creating algorithms, which would need code, but you're doing those kind of in the background or using someone else's and just throwing them at data sets. That's my interpretation of this, which is a little bit biased and old-fashioned, I admit. But this gives you an interesting sense of the direction that this is going. But we're not really talking about coding today, so I'll move on from this. I want to talk a little bit about interactive data tools. So back in the day, when I worked in the health department and someone was asking me, what % of people in King County, Washington are uninsured? I had to write that code that you saw, and I had to have my data set and ask Stata, put the data set into Stata and ask Stata to pop that number out for me. So I had to do an analysis. It was not available to the people that were asking me. It was not online. It was fantastic job security for all of us epidemiologists doing this work, until it started being that more and more of it went online, which we completely believed in, but meant that people were not having to ask us those basic questions anymore. And if any of you in this session are librarians, it's the same thing for reference questions. The more and more it goes online, the less that people have to ask basic questions. And part of this is what I'm thinking of, or what I call the rise of interactive data tools. So I just think that there's more and more of these out there, and there's more and more data available in them. So we're going to look at 4, but I do want to make the point at the bottom, which is, don't forget the possibility of data requests. So this is what I used to do at the health department, and there is still someone in the King County Health Department that takes data requests. And for example, if there's a school district that wants a particular analysis of statewide birth data, and they are not allowed to have those data because of privacy concerns, but they need the analysis to be done. They can ask the health department, could you please run this thing for me, which I'm not allowed to run myself. When I was in the public library, I don't know if this is true in California as much, but certainly up here, there's a regional economist. So there's a state economist, and her name was Ms. Sherman, and we sent her data requests all the time. And it had to be something worthy, not like, what's the average per capita income in Washington state that you could find online, but something that she would have the data for that you are not allowed to have, but she would run that data for you. Even the Census Bureau will do specialized data requests. So before you actually think that you have to get the data, or before you think that you're locked out of analyzing the data because it's not available to you, remember that you can consider data requests. And it can be hard to find the right person to write to. So we librarians can help you with that. Okay, so looking at US Census data, there's so many ways to explore census data. And I think of this as kind of like the bedrock of looking at code-free data analysis. The Census Bureau is very, very motivated to give you a lot of content that you don't have to work very hard to get. That's their motivation. Generally, it can be very complicated to get their data because it's a complicated data set. So they do the best they can, but I don't want you going in thinking that like it's just going to be super easy. So this is a screenshot from data.census.gov. But you can get census data from a lot of other platforms. So IPMS will give you that microdata, which can be quite exciting because you can get at things that will not be in these tables. I wish I could explain that a little more. I don't feel like I have the most time, but if you want me to sort of talk about that more later, I can. ICPSR, which stands for Inter-University Consortium for Political and Social Research, worst name ever, has census data. And there are some, at least at Berkeley, library databases, Social Explorer being a notable one, that are much more user-friendly and easy to manipulate and conceptualize. You might want to see if any of these are listed or at your campus and enter the census data through them. But as great as these tools are, they are not a substitute for understanding how the census works and what the terms are. So for example, do you own or rent your house? The word for that is tenure, which you would not necessarily come up with. Are you foreign born? What country were you born in? The term for that is place of birth. And as you use the census data more, you start getting used to the terms the Census Bureau uses, but they can be a little bit impenetrable. And it will help you a lot if you do a little bit of background before you do your analysis. In fact, I think you won't be surprised to hear me say it will always help you in doing any analysis, whether code-free or not, to really understand your data and how they were collected. So I've given you a link here in the second bullet point about sort of getting started and learning some of the terms and how the data collection is done. Third bullet point on this screen, check out the upper right. You'll see tables, maps, profiles, microdata. I would just explore all of that stuff if you have any interest. And then finally, there's something called Census Academy, which I've linked to here. And you can check out video tutorials. And they're actually really good and not too long. It's not like you have to sit there for an hour. So, hopefully that all makes sense. And then I'm just like warning you, the next slide's a little alarming, but I will deconstruct it. So this is what you would get if you did a search. So I'll back up for a second. So they're saying, look, try searching for grocery stores in Georgia in 2017. Making it seem like that's exactly what they're going to pop out one table. But if you do an easy search like that, and you can see at the top, I searched for commute in California 2018. And you can see in the upper left, the two filters that say California and 2018. I mean, it read my question beautifully. And there's 1,400 results. So it can be a little bit alarming, and you just have to kind of give yourself some time to work through it. But the 1,400 results are listed in that middle column. And then in the right-hand column, it's given what it thinks is the most likely thing that I would want. And it's actually, I can get some pretty good data there. I'm seeing how many workers are 16 years of older. And then I'm seeing the estimated numbers of people. Is it people or percentages? Hard for me to see from here. That use each type of commuting method. So this is kind of what you'd be dealing with. It's because the Census Bureau wants to give you everything. It's so interested in using everything. It can be a bit overwhelming. So I guess my response to this would be, if you need help, we can always help you find the right person on your campus to sort of work with you a little bit on this. So that's census, United States Census. And actually, I'm realizing I didn't even say what that is, but hopefully it's familiar to at least some of you, which is the two main programs are the decennial census, which is collected every 10 years, and then the American Community Survey, which gathers more detailed information, and it's continuously administered. Then I want to talk about what I call administrative and civic data. So administrative is meaning like things that are collected by the government. And you know the government's collecting lots of things about us, like our electricity use and our property taxes and our spending habits and all sorts of things, health. So there are many sources of administrative data. And then when I say civic data, I'm generally meaning data that's collected more in smaller localities. The first thing I would suggest is if you have a question that might use data like that, go straight to the source. Go to whatever agency you think is collecting that information. And we librarians can help you figure out what agency that might be and see if they have any interactive tools for you to look at. You might also want to look for annual reports from that agency. You could also see whether they have something called a data portal. And you would generally, if you search like Berkeley open data, if the city of Berkeley has an open data portal, that's where you'll go. And then there'll be lots of data sets listed. Like in King County, Washington, there used to be, I haven't looked at it recently, restaurant inspections, swimming pool inspections, crime data, things like that, and separate data sets that dealt with different regions or areas of King County and that you could download. I have on many occasions been asked for these kinds of questions about other countries. Often there are statistical agencies within the country, although you might need some language ability to read those, or international organizations such as the UN will collect data. And a lot of the time you can access them through tools that mean you don't have to do original data analysis. But you need to understand how the data was collected and what it represents. I do also want to mention in the final bullet, the Google hack site:/gov, which is fantastic. What it will do is you can do your search like open data site:/gov, and it will give you only results that end in .gov. So it's a great way to kind of narrow your search. And then I'm listing some actual search tools. So I would like for us, search terms, sorry. So I would like for us to look at BRFIS data. So BRFIS is Behavioral Risk Factor Surveillance System, and we used it heavily in the health department because it had very, very detailed information down to pretty small areas. That's a big challenge always, is getting data for small areas. So remember that code that I wrote that you saw earlier where I was trying to get at percentage with insurance or not insurance in King County, Washington? Well, what about for California in the BRFIS website? I can get code-free that exact same table. I could not have gotten this table, I assure you, even probably 15 years ago, or maybe even 10 years ago. But as time has gone on, there's more and more that's available, more and more interactively. So even if you thought that 2 to 5 years ago, you couldn't get this thing online, look again. So this is exactly what I showed you before. In this case, California State, 7% do not have some insurance. And I did it code free. So hopefully we're all pretty much caught up there. I'd like to now look quickly at ICPSR, that online analysis option that I mentioned. So again, ICPSR, Inter-University Consortium, et cetera, et cetera. It's a really amazing repository for social sciences data. You do need to have an account. My understanding is that all UC campuses have this, so you should all be able to get one. There's a lot of data sets. Most of them are curated. So if you did a search for health insurance, which I did here, you get a lot of results. But if you look at the very bottom left of this screenshot, it says online analysis. So for those 865 data sets, you do not need to use code. You can analyze it with no code, which is why I'm showing it to you. So I picked this one, Health Reform Monitoring Survey, because it's a little newer. It's from 2019. So when you click on it and you go into the data set, this is what it looks like. And you can see in that middle, it says Analyze Online SDA. So you would click on that. And by the way, just at the bottom right, you can see it's been downloaded. The whole data set's been downloaded 517 times, which is quite amazing, pretty good. But we're going to click on Analyze Online. And this is what it looks like. So, it's not slick. You have to, it's a little bit, you have to kind of get used to it. So, I mean, I wish I could sort of say, oh, it's super easy and, you can just pop the stuff out. Well, not exactly. But basically what you're doing is down the left-hand side, you're looking at the questions that got asked, and then you're popping them into the boxes on the right to organize how you want the data to come out. So in this case, I said, I want the rows to be from question 1, which I put above, it's general health. And then I want the columns to be, where do you usually go when you're sick or need advice? So the question that would be answered is, do people's choice of where they go for healthcare differ between people with different health status? Excuse me again. And then there you go. It pops out for you, no code. So this can be very, very useful, especially if, you just need to sort of play around with data and ask questions and see how they get answered by a data set without, actually having to delve too much. You can see whether a particular data set would work for your purposes. So that's what ICPSR looks like. Then I have SDA. So remember where it said Analyze Online SDA? Well, SDA is Survey Documentation and Analysis. It's actually the tool that underlies the data analysis, and it's what ICPSR uses to drive its online analysis. So it's pretty cool. It was created at Berkeley. I'm not going to spend a lot of time on this. I think that it's a little bit more complicated to use. It's a little harder to sort of show you easily. There are tutorials, but it's so powerful that I wanted you to know about it as an option. And one of my favorite analysts at ICPSR says, I don't even bother with some of the other tools. I just use SDA because it works so well. So notice that SDA, you can look, there's 3 different data sets that it's really, really good at organizing for you. But for the general social survey, which was what the SDA was kind of created for, now there's an online interactive tool. So to be honest, if you were asking me, I would say, I don't really think you should learn SDA for the GSS, which is the General Social Survey. It's a very, very highly regarded, long-running social science survey. You can see it ran from 1972, and they're still doing it in 2022. Super, super interesting stuff. But I would just say use the online interactive tool. And there's more and more of these. So I think you get the idea about the online interactive tool. So let's move on. I want to talk now about uploading your own data to tools that will actually do analyses for you rather in the background, rather than you having to do any coding. Where could you get data if you wanted to play around? Well, you could try Google Dataset Search. We'll look at that in a second. Many of the library databases include data. We can talk about that more if you want. Civic data portals, we talked about that. I've actually sometimes when I'm teaching just Googled fun data sets, and there's lists out there of fun data sets like, did you know there was a census of Burning Man or Major League Baseball statistics or something like that. So I'm going to show you 3 tools, actually 2.5, because I had a fail with one of them, but I think it's good for you to see a fail. I do also want to say that the limitations of using your own data, these tools are pretty basic. So they can't do as many sophisticated things as the interactive tools I've been showing you. So if you wanted to do anything more complicated, they can be a little bit limited. You may have to clean your data. We'll talk about that in a second. And once more, if I haven't said it enough times, you need to know how the data were collected and what they represent. And let me just stop for a second. I keep saying that, but what does it mean? The example I tend to give about this is when I was an epidemiologist, as you can imagine, we used Washington State birth data pretty extensively. The prenatal care, the initiation of prenatal care, which is a very important question about the health of the baby, was so bad quality data and so much missing data that you could hardly even use it. And in fact, one hospital that was responsible for 10% of all Washington State's births did not fill it out on the birth certificate. So if you didn't know that and you were using that piece of data about prenatal care without knowing that it was very problematic, you would kind of be making claims that were not substantiated, whatever. I mean, people could come after you and say, you can't say that. So the more you know the data, the better. So this is what a Google dataset search looks like. And it's pretty straightforward. I love that you can see the scholarly articles that cite it. So if that matters to what you're doing, that's a useful feature. You can see usage rights, et cetera, across the top. And then you can see that cite : filter, which is so useful. Cite : gov, cite : edu, cite : canada.ca. In this case, we're looking for Canadian government data sets. So you get the sense of how useful that can be. So for me to show you these tools, I just think it's so much more fun if you're doing data exploration and learning to do something fun. And so back in the day, I actually took a civic data course, and you were supposed to kind of do a project with a civic data set. And I found this archaeology data set, and it's from this house from the early 1700s, and they excavated it basically, and they did a data set of all the stuff that came out of the ground from that house. Totally fine if you don't think that's as cool as I think it is. You'll find something that you think is cool. So this is what it looks like. This is the raw data. So you can see like column E, where was it found? The ones on this screen are in the garden. You can see what kind of material was it? Was it fauna or flora, animals or plants, minerals, stone, ceramic, glass? And then you can move over, and the right-hand column is function. And what was it used for? A lot of food and beverage, as you can see. You'll also notice, like in column L, see all those zeros? The analysis tool might not like those zeros. You might have to figure out some other method for coding those, which would mean you would do like search and replace, and wherever it says 0, say missing. Also notice that all of this data is pretty much text data. So that can be a problem for some, as we'll see. But this is what the raw data looks like. It happens to be an Excel spreadsheet, but it could as easily be in a Google Sheet. So first I went into raw graphs. I like raw graphs a lot. I uploaded the file in CSV format, and then I got all these choices for possibilities of displaying the data. So it's putting the data into a display, but as we'll talk about with data visualizations, The display is the analysis. It doesn't mean that you have to actually do any analysis or coding first. A good display program, visualization program, will pull the data in and do some of that for you. And you can see all the different choices it's giving you. And underneath each one, it says, this is what it's good for. So even actually, if you're not doing a visualization, this is actually such a great thing that it's, and of course, it only goes down to the C's. So there's a ton more choices that I didn't put in the screenshot. But if you're looking for like what chart is best for a certain kind of data, you could actually open this up and see what it says. And this is what came out when I fed the archaeology data into it. So this is exactly what I wanted. Exactly. You can see it has a little bar at the top for the zeros, which, I could have coded those missing or whatever. But what I wanted to get a sense of was how far did the food and beverage use of the artifacts that were found outstrip all the other uses. And you can see quite a bit. The only adjustment I had to do to this was I had to move the left margin over. So if you see about a third of the way down, it says margin left. I moved it to 170 so that I could see all of the words on that down that left column, but otherwise I didn't have to do anything. So I just think this is a really useful one, straightforward. It gave me exactly what I wanted. So then I tried Data Wrapper, which people love Data Wrapper. So I was really ready for a great experience. And my understanding was that it had much more functionality. So so truth in advertising, I know that you will all deeply, deeply empathize with me, but I did all these slides last night. So I'm not all, but this particular one anyway. And I spent about 45 minutes on it. I could not get it to work. So I just sort of said, okay, I'll just admit the fail. So fails happen and you are seeing my fail. And I encourage you all to put in the collaborative notes what I did wrong or why it works great for you. Totally welcome that. It's me, it's not the tool. But just to show you, I tried cleaning the data. So it didn't see me. I thought maybe it doesn't like those zeros. I should change them to missing. So I did that. Then it was saying I had only text. I had done a subset with only a few columns and it said, oh, you don't have anything numerical. So I added that straight column back in. And then I was trying all these different chart types and it was like, no, you don't have the right configuration of your data to use these chart types. I tried changing the values in the Excel spreadsheet. I mean, I was doing all of this stuff. I couldn't get it to do anything but this, which is not helpful to me. So this is every single instance. I wanted it to collect all the food and beverage together and collect all of the heating and plumbing together like raw graphs did. I never got it to do it. I did actually even do the tutorial because I was like, oh, okay, this is my arrogance that I thought I could just come in and do it. I better watch the tutorial, but I still couldn't do it. So let's just say, if you want to use Data Wrapper, find someone that knows how to do it, not me, because I'm obviously not a good user of it, but it's supposed to be fantastic. And then this is one of my favorites, which I came across when I did my civic data course. It's databasic.io and it has 4 different tools. And you can do all sorts of different things. It can give you word count, word clouds on the left. It can give you networking on the right. I like WTF CSV. So it's just kind of what's happening with your CSV file. And so you just upload your file and this is what you get. So each of those different columns that we saw in the raw data are coming out as a separate kind of visualization. So you can see that function 1 at the bottom left, and it's done exactly what I wanted again, which is the relative rankings of each of the different uses that the original people were putting these artifacts to. And food and beverage comes out way in front. So this is what I wanted, was just a quick visualization. This took me 3 minutes tops. It's such a good way to kind of think to yourself, what do I have in this data set anyway? It has some fun samples. There's a sample of the Titanic. And so they have a whole sort of set of things of how many people were first class, second class, third class. You can look at how many people survived by the class of ship they were on, stuff like that. And it just pops out. You don't have to do any code. So then I wanted to move on to using familiar tools. I think in the old days, so the way I kind of think about this is like in the old days, when you thought about physicians and nurses, generally professionally, and there's articles about this, those were very, very separate roles, and the tasks that they were allowed to or felt competent to perform were very different and very delineated. But over time, they kind of merged together, and now many nurse practitioners are operating at the same level as physicians did 30 to 40 years ago. And in fact, maybe you see them for your healthcare and they're trained at that same level and doing those same functions. It's kind of not a nice way to put it, because personally, I think nurses are better at a lot of things than physicians. And I speak that. I have a medical family. So yeah. Okay, I'm digging myself a hole here. But anyway, so to me, it's the same thing with Excel and like a statistical package like SPSS. Over time, Excel has taken over many of the same functions and does them as well or better. So if you're familiar with Excel, that gives you a lot of power. If you've used Excel or Google Sheets for some time, you don't have to go out and learn a new thing. You only have to learn a separate function in a tool you already know. So that's kind of the point that I'm trying to make here. So if you haven't looked at the data analysis functions that are available in Excel, I probably could have done most of my work as an epidemiologist using this. We did not have it back in the day, but there's forecasting, prediction, removal of duplicates, filtering, very, very sophisticated queries. There's all sorts of things available here in this tab. The reason I put in the title of the slide, but, is that this does not always work as well for Mac. And I know that many of you use a Mac. So all I can say is, ugh, so frustrating. But I do encourage you to explore these various topics. And there's a lot of fantastic tutorials online. This is a very good site. It's from Princeton University. And you can see down the left side, it's helping you do descriptive statistics. So if all you really want is some basic description of what the data set contains, this is going to be really helpful to you. And then underneath number 13, you can see there's pivot tables, graphs, and one-way ANOVA. Those are getting into some more sophisticated analysis, and still no problem doing those in Excel. And the tutorials in this are really good. I also at the bottom have another link to tutorials. But you still might want to do something more sophisticated if you're being asked for a class or to compare to an article or something like that. So if there's a specific thing that you want that you don't see anywhere obvious, Google it. So if you Google, can I run a t-test in Excel? You will get this. And the answer is yes. And that's a pretty sophisticated test. You did not used to be able to do that in Excel, I promise you. So if you haven't been to Excel recently, check it out. Google Sheets. So because I've been an Excel person for so long, and because our library gives staff a PC, I am a little bit Excel biased and Excel heavy. I'm trying to move over more into Google Sheets. I was super surprised at how much you can do in Google Sheets. Least squares linear regression and Monte Carlo simulation, those are some really sophisticated statistical techniques. And the fact that you can do them in Google Sheets is amazing. And I think it's because it's not a proprietary product as much. Google is, but not quite in the same way Microsoft is. And so there's more add-ons and extensions that people are developing, kind of the way that happens with R, that coding language, that allow you to do these really amazingly intense things. So just wanted to make the point that there's like so much available there. It's kind of cool. And then finally, I will be talking on Friday when I do my qualitative data analysis presentation about Taget, which is qualitative data analysis tool. And here's an example of tagging sections of text. So if your data are actually transcripts or textual. I mean, this is kind of coding. I cannot deny that it's kind of coding, really, but it's still doing analysis without having to specifically learn code. Taget is very, very user-friendly. It's on the more basic side, but super user-friendly for that kind of data. And then the last main topic that I want to cover, and it looks like I've been talking fast, so I'll have time, are data visualization tools. So I think certainly in the older days, maybe less now, because I think there was just so much more exciting now. People are using things in such creative and combined ways. But not too long ago, you would do the data analysis first, and then you would do the visualization. So you wanted to see what the data told you and then do the visualization. But I think people are moving more and more to not necessarily knowing the patterns in the data, but the visualization tools are so good that they will give you some of the patterns. So the recognizing the patterns and analyzing the data can be done with the visualization tool, but then you can also convey the data in such strong and wonderful ways. So the first one that no surprise, you've probably heard of it, but if you haven't, check it out, is Tableau. It's one of the most powerful, commonly used data visualization tools. It does visualizations, but it actually can be used for some pretty sophisticated data management. You can do data dashboards, that kind of thing. I'm not sure if every campus, so in the Love Data Week things, we're supposed to be only talking about tools that are available on every campus. And I don't know if every campus has a license, but there's a free version that's available to everyone. So no matter who you are watching this, you can use Taget. Lots of tutorials. I have some links here. I also like the guide from Vanderbilt Library, which has some links to like user forums. Google Sheets has great user forums. Excel does, but not quite so much. But user forums are a great way to just say, look, I've tried this and this and this. I feel like this tool should be able to do this. Anybody have experience? And you'll get really helpful answers. I didn't really realize even that you could integrate Tableau and Excel. So that for me is an interesting thing. So the way to think about Tableau is like raw graphs, but on steroids. There is a learning curve. So for a lot of this, you have to know the data and how they were collected, as I keep saying, but it's not like the tools are nothing to learn. And then I wanted to sort of talk about infographics packages. So hopefully that term is somewhat familiar. They often tend to be kind of vertical, and it'll have like 6 or so visualizations going down with some text, and they're combined to create a story generally. So I think of it as linking multiple connected visualizations, vibrant, user-friendly. I have a link here to a guide that compares 5 main tools, an infographic planning worksheet, and just a reminder that you don't have to do your individual visualizations in this tool. You can do them elsewhere and import them. I'm sort of using these terms without being specific about what I mean. So I want to show you this infographic and just pick it apart a little bit. In a way, this is not the best infographic in terms visually, because it doesn't immediately convey what you don't immediately understand what it means. You actually have to dig into it to understand what it means. So that's kind of a minus, because generally, if you're doing something, you want to have it be very direct. And it's not really telling a story the way that some infographics do. It's not combining visualizations. But when you start to look at it and think about it, it's amazing. First of all, it's beautiful to look at. It's compelling. What it's doing is, we don't do that in this country, but in Great Britain, for Armistice Day or Remembrance Day, people wear red poppies. They have little poppies on their lapel. So the image is poppies. The size of the poppy represents the number of deaths, and it's military deaths. It's a lot of deaths. The stems represent time. So the origin of the stem is when the war started, and then the sweep of the stem to the right is how long the war lasted, and the flower comes when the war ended. The colors of the flowers represent geographic areas. And then across the bottom, you have time. That one big sweep to the right is the Israel-Palestine war. So it's a very sad thing to see. But this one image that it's just sort of a nice image to look at. There's so much data in it. So you have data on deaths, you have data on duration of the war, you have duration of time, you have region, and there's something else, but I forget. The name of the war. You can click on these and find out what war they refer to. So it's a very, very sophisticated, complex infographic. So this is just one way to think about it. If you are really wanting to delve into infographics and visual display of information, check out newspapers that do it well. The New York Times and the Wall Street Journal are two that come to mind. And then to finish up, just want to talk about all of these things are now combining into something that's called data storytelling or digital storytelling or data narratives, where you'll actually have a written report, but the data analyses in it are constructed so that they do tell a story, and they include images and other tools. So the quote from James Madison University is, "A data storytelling is weaving a range of information into your text to bring your story to life, displaying data, creating graphics, showing image galleries, and creating interactive elements so your readers can explore and experience your story more deeply." In that third bullet point, I talk about checking out story maps. Story maps is a tool where you can literally take a map and on geographic points of the map, which can be coded geographically, the data and all sorts of images are pinned that you can go out to and give you more context for that. So imagine the race to the South Pole, Amundsen and Scott. There could be a story map about that where you trace their journey day by day, pinned to the map, and how that played out, sadly, for Scott. And then two more links here. Here is the research methods guide that I just wanted to show you. This is from me. And I was just saying to Erin earlier, I think I should put in another tab after that. That's called Code-Free Data Analysis, and pull all this stuff in. And then last but not least, this is how to find help. I know we're kind of close to the time, but it looks like there might be a little bit of time for questions. The visual here, if you've ever seen the work of Sasha Chua on Flickr, I just think she's really amazing. She does these incredible kind of note-taking visuals, but I love the content of them too. So I encourage you to explore her work. So we will be getting I will be getting the link to the slides, the collaborative notes. We will put the chat into the collaborative notes to everyone who's registered. At least I hope I will, if my LibCal account cooperates. I'm happy to help as I can, but I'm, a Berkeley person. I'm only one person, so I can't help all of you as much as I would love to. But I'll always try and find you a good referral. And we'll be looking for the data people on your campus, or I can maybe perhaps find you tutorials online. And then if this has kind of whetted your appetite to maybe learn a little coding, I've started you off with a link here. So I think I will escape and come back and stop sharing.
Thanks, Anne. Yeah, and I just want to, I'll just quickly follow up based on the chat. So yeah, we've had, I unfortunately, apologies to you all, was not able to keep up with the links. So we will, if you have the link to the collaborative notes document, we will try to add, probably sooner than it would be on the website, a link to the slides. So then you'd be able to get access there. But as Anne said, we have, I'll put the link to that collaborative notes document in the chat one more time. But you'll, these slides, the recording will be available on the Love Data Week website. So fear not, it will appear.
I cannot wait to see the notes. Thank you for all your thanks, everyone. I really, really enjoyed this. I learned a ton myself. Any questions in the chat, Erin, that you think maybe confusion, or if anybody wants to unmute themselves at this point, feel free.
I would say that. I will also say there's kind of one question about that for you that said, how about Qualtrics? Can you sort of speak to Qualtrics
Qualtrics.
in this context?
Very good point. See, now I don't think of Qualtrics as a data analysis tool. So if we wanted to get into data collection tools, to me, Qualtrics would be equivalent to Google Forms. So
Mm,
it's not
mm,
the way I think about it is it's not the data itself, it's the way you collect the data. And it's super important because how you ask the questions determines the data that will come out. And I know that in Qualtrics, you can see the data you've collected, but generally you're exporting them to analyze elsewhere. But fight me. If maybe others see it
I'll take
differently.
challengers. I'll say we are at time. I know I can stay a little bit longer, and I don't know about your schedule, but if
I
folks,
can stay a little bit longer. Yeah.
okay, so if folks want to stay to ask some questions, I think we should have a little bit of time. If you have to leave us again, check the Love Data Week website for the materials. And thanks for being here, of course. I will stop the recording now, and then we
Oh,
can
Melissa,
chat
I'm
some more if
saying, yeah.
people want to hang out.